Alright, let's have a look at what else we've got going on here as far as grounds. Okay, we've got a whole mess of wires. Of course, we have a star ground array on this mixer. We've got a bundle that heads off this way. Those loop back up to our master section input-output jacks. And then we've got 4 bundles that head off this way. Each of the 4 bundles goes to 4 PCBs, 4 groups of 4 PCBs of 8 channels each. Okay, come up, they've got them looped up, and you got one set that goes here, they travel underneath, you got the bundle loops up, and you got a group that goes here, and then we've got the same thing here all the way down to the end. And what they did is just took the 8th jack on each one, the pin 1 connection, because we've got pin 1 of this XLR jack right here, which goes to the ground trace, which occupies most of this XLR PCB, and each one of those pin 1 connections goes to a connector that interfaces with the channel strip. But on the last one they just tagged on a second wire, and that goes all the way back down here. And each of the PCBs does that. Our XLR jack PCB is pretty simple. There's no other components on it. It's just pins 1, 2, and 3 to posts 1, 2, 3, and then on to the channel strip. All naturally, because we've only got this one connection here, that's what ties us back to chassis. This brown area that you can see, covers the bulk of the PCB, is all interconnected. I've mentioned in another video that we've got some issues with, on each of these XLR jacks there's a variable conductivity between pin 1 and the shell of the jack, and between the shell and the back plane. So we've got secondary connection to the ground reference. Some of these are in the mega ohm range, some are in the kiloohm range, and I've got some that are as open as 17.5 ohms, I think, was the least amount of resistance I measured. So that's an issue. But we'll leave that for now. These other jack PCBs, I pulled these off. This one, this is for the direct out jacks, post fader direct out, and this is the only one that really has any components on it. You have these resistors, and I refreshed my memory what that's all about. This is an unbalanced output that is either -10 dBV or +4 dBu. The native level is +4 dBu, and the way that it works is it is a TRS jack. When you insert a TS plug all the way, you are getting the straight +4 dBu nominal signal. This is the positive terminal, and it goes over to here, hops over here. There's just a 0 ohm link, and up here to that third pin on the jack. If you insert it halfway, then you're contacting this one, and that comes down to here, and you've got a there's a resistor here. So you come up from your positive over to this resistor here, and then there's a resistor that goes to ground, and your signal goes up to here. So you get your minus 10 dBV nominal. Same thing here though. You've got ground trace that goes all the way around. They're all interconnected. These jacks are plastic, so there's no issue with secondary connection to the chassis through the jack because they're plastic, and they also have these fiber washers that go in between, and the nuts that connect these to the back plane are plastic as well. But we do have our ground reference wire that goes all the way back to our star ground. The insert jack PCB and the line in jack PCB are more benign. No resistors on there. Obviously unbalanced send and return on the insert PCB, and then our line in is balanced. But they both have basically the same makeup. So that's what's happening there. And then next up we'll jump into the input strip and have a look at what's going on there. So again, so far it's looking like the rest of the system, the audio system ground, comes from the star ground and through the jack PCBs, through these interface cables. These are our input-output connectors that connect up to the channel strip. So we'll have a look at a channel strip.